Hello, and thank you for joining us today. Before we get started, just an overview of what to expect. So I will start with an intro to GW, then I'm going to turn it over to our faculty presenters who will share more about the graduate programs in chemistry. The presentation is going to be anywhere from like 20 to 30 minutes, and then we'll have just time for Q&A. We do have a hard stop at 6:45, so make sure if you have your questions to send them through that Q&A. You can ask them as you think of them, even during the presentation. If there's anything we can't reply to within the Q&A, we will answer it live once we conclude the presentation portion. Again, hi everyone. I am Seb. I am the Assistant Director for Graduate Recruitment here in the Office of Graduate Studies for the Columbia College of Arts and Sciences at the George Washington University. We welcome you to our chemistry graduate programs information session, and we're going to start with an overview of GW. So the George Washington University is located here in the heart of Washington, D.C. As the largest institution of higher education in the U.S. Capitol, GW welcomes 11,000 undergraduates and nearly 14,000 graduate students from over 130 countries, helping create a vibrant and global community. Our main campus is just 4 blocks from the White House and close to world-renowned government agencies, nonprofits, and private sector organizations, giving students unparalleled opportunities for internships, research, and career advancement. Within GW, the College of Arts and Sciences, or CCAS as we call it, is the largest academic unit and is home to 5,000 undergraduates and over 2,000 graduate students. We also offer more than 90 graduate programs. Nearly 500 full-time faculty work within CCAS dedicated to collaboration, critical thinking, and applied learning. With an average of $21 million in annual research funding, CCAS students and faculty help advance innovation and tackle real-world challenges. So now I'm pleased to turn it over to our faculty presenters to tell you more about the graduate programs in chemistry.
Hello, my name is Latschenko. I'm Associate Professor at Chemistry Department of George Washington University. We're a relatively small department, but we have a bold vision. We strive to be internationally recognized as a premier chemistry department for education, innovation, and cross-disciplinary research, of course, in the U.S. capital. So our mission is to advance world-class research and education in the chemical sciences to improve people's lives, global well-being. Our values is first and foremost to accelerate discovery, to improve global well-being, to guide students in their pursuit of knowledge and innovation, foster an open culture in diversity and inclusion, and promote collaborative community dedicated to excellence, and also develop effective professionals in the interdisciplinary fields of science, which is nowadays is very, very common. So we are located in a dedicated state-of-the-art science and engineering building called Science and Engineering Hall, with the total floor space about 500,000 square feet. It's a huge building. You can see it on the right. What we have in this building is numerous teaching and research laboratories, and we are next to the Foggy Bottom subway station. So, as I already mentioned, there are numerous laboratories in the Science and Engineering Hall, but our department, the chemistry department, occupying a significant portion of that building. We actually basically located on each floor. So, in the laboratory, students, graduate student, faculty work basically shoulder to shoulder in close proximity. That allows us to grow together and to train graduate students and guide the graduate students to their PhD degree. Okay. If you join the department, you will attain a level of technical ability and knowledge in chemistry and related sciences so you would be able to excel as a professional in your chosen discipline. You will gain hand-on research experience using technical and problem-solving skills. So you can contribute to the research field. You will develop professional communication and presentation skill, and you will be well positioned to obtain employment in chemistry-related fields as well, of course. So program highlights, individualized teaching and mentoring. Our student to faculty ratio is actually quite small. It's like 3 students per 1 faculty member. We are a close-knit community of graduate students. We have 40, 50 doctoral students and 10, maybe 15, 20 master students. Okay, so we're a moderate-sized department. We're not a huge department. We have 15 research active faculty. This ensures a great specialized attention to each graduate student we mentor. Our size promotes strong connection and academic foundation that lasts beyond GW. We have an extensive network of alumni. So our curriculum is based on 3 core courses plus 2 elective courses. So we're talking about 5 courses total. Students have the chance to craft their own course of study. You have a chance to pick up the particular exams or particular courses. This helps our students to develop the tools they need to succeed in their chosen field of chemistry. Okay, so here are some examples of the core course, graduate core course, which we offer. There is a spectrum chemical analysis. There is a course on chemical bonding. There's a course on molecular spectroscopy. Of course, organic chemistry is a big part of our program. So we teach organic metallic chemistry, advanced organic chemistry, advanced organic chemistry part 2, and organic chemistry. Polymer chemistry, that's a relatively new addition. Biomedical mass spectrometry, chemistry of inorganic materials, physical organic chemistry, and of course, chemical thermodynamics. So speaking opportunities, it's all about developing communication and presentation, data representation skill. So our master students are supposed to give a 1 30-minute presentation to the department, 1 30-minute talk, essentially. PhD students are required or given an opportunity to present 30-minute talk early in their PhD career, and then 60-minute full seminar at the end of the PhD track. Students take advantage of numerous opportunities for outside posters and talks about their work. We typically our graduate students attend numerous, several national or international conferences during their term. Okay, a few words about what, like, year by year the program looks like. During the first semester, first semester, students undergo rotation in 3 labs. What it means, they just kind of spend like a few weeks or a month or so in a particular group, research group, and then so they get a feel and an impression what's going on at different laboratories. They're supposed to select the research director as a result of these rotations and identify the core graduate courses they need to take. Second semester, the students usually form the dissertation research committee and kind of finalize and fine-tune their program studies. Second year, what we have is a program which is called the Cumulative or Comprehensive Exams. So comprehensive exams usually take a year or a little bit more to complete. So in order to complete cumulative exams, students need to earn 10 points in 7 exams, so 12 points in 10 exams. This is followed by a 30-minute seminar and completion of coursework. Okay, third year is highlighted by the so-called candidacy exam before the end of the 6th semester, where the people finalize their program of PhD research and studies. 4th and 5th semester, students are supposed to give 1-hour seminar and, of course, progress to the dissertation, defense, and graduation. All right, I'm going to skip this particular point because my colleagues are going to be able to address the master students funding. So I'm going to move to PhD funding right away. So PhD funding, our PhD students are fully supported. That means, there's a tuition, this is free tuition, and there's also a stipend of some sort, which is guaranteed for 5 years. Students most often served as a graduate teaching assistants, GAs, during the first and second year. Research funding can be used to support doctoral students during the later years. Okay, so if you have any question about the PhD program and the MS and EGCMS, please forward your inquiries to gradapps@gw.edu. General question about GW chemistry, gwchem@gw.edu. That's it.
All right, thanks, Vlad. Good evening, everyone. Thanks for tuning in. I'm Jakub Kostal. I'm the director of the Environmental and Green Chemistry program in the chemistry department. And I just want to tell you a little bit about it, and we can get into some of the details in the questions. So we have some stuff here on the mission. I would say the primary goal of our program is that it's what I would say is value driven. It's not diploma driven. So the goal is to impart a certain skill set on you to then go into the real world and make a difference at the intersect of what's green chemistry, what's environmental chemistry, what's toxicology. And I have to say that a lot of our students that have graduated from this program have done exactly that. So if you're looking for a program that is generating tangible impact on the world that surrounds you and you care for the environment, this may be the right program for you. Let's skip to the next. Perfect. So just as kind of, alignment with the job sector, what we have been seeing, and this pertains to the US, but it's true globally as well, there has been a huge rise of green jobs as a fraction of the total job market. DC, I think that's the next slide potentially, it's particularly good for this. DC has, via government and a lot of NGOs, non-governmental organizations that work at this field of green chemistry and environmental chemistry and sustainability. So these NGOs and government organizations are particularly suited for the kind of skill set that you build in this program. So if you're looking for local employers, it's another good reason to come to our program because we are based in DC next to these agencies. As just the structure of the program, you will take 30 credits within the chemistry department and broadly at the university. You can also leverage courses from the broader consortium with Georgetown and University of Maryland. As part of the 30 credits, 18 come from 5 core courses and a capstone. I'm going to talk a little bit about the 5 core courses and then spend more time on the capstone. The capstone project is, you can think of this as sort of a hands-on project with external partners to the programs that tries to tackle real-world challenges, again, at this intersect of green chemistry, tox, and environmental chemistry. This is just a broader list of our partners across government, NGOs, academia. You can see it's extensive, and we sort of source a select board of experts who advise our program and then who help us figure out what are the right projects for our students to tackle. So you can always make sure that you're sort of up to date with where the field is and making sure that the skill set that you develop through these projects is applicable in the job market after you graduate. As far as the examples of some of the capstone projects, this is from the past several years. Students have worked in collaboration with the US EPA and a law firm in the US in the DC area called SEAL on environmental justice and equitable distribution of green chemistry across indigenous communities. That we have looked at things like developing certain materials that have certain properties but are safer towards human and environmental health. The example here was working with a small startup from Switzerland called Dimpora that came out of ETH Zurich on building essentially a replacement for Gore-Tex, which is a waterproof breathable fabric used in outdoor apparel. This was a collaborative project, not just with the startup, but also with a SaferMate, which is a venture fund that looks into investing in sustainable technologies, with Patagonia, who was looking to potentially incorporate this startup in their supply chain. Eastman, who is a manufacturer of plastic, so they could be the potential manufacturer on a larger scale of these membranes. And NRDC, which is a Natural Resources Defense Fund. It's a lobby organization, activist organization in the DC area. And the last project is collaboration with USGS on looking into how PFAS, which is a very important and highly of concern chemical class, how that PFAS class or PFAS chemicals are distributed in the environment, and how some microbial classes can help degrade these chemicals. So as far as outside of these, the core courses and the capstone, you will take 12 credits from elective classes. These are sort of custom tailored to your specific needs. So you would meet with the advisors in the program to discuss what you want to do with the degree after you leave. And that's typically the kind of a initial conversation that leads to your selection of these electives, whether it's from the chemistry department or the GW School of Public Health or School of International Affairs, Public Policy, Engineering, Applied Science. So it spans the whole gamut of, say, very technically oriented disciplines to very policy, law, or management oriented classes. So really, the world is kind of your oyster, and depending on what you want to do with the degree, we can find a good alignment through these electives. I mentioned a consortium, so you're not tied to just classes at GW. We leverage great coursework at Georgetown University and Maryland. I especially want to highlight here the EMAP program. So Georgetown Chemistry Department runs sort of a sister program to what we do at GW called EMAP, which is Environmental Meteorology program that covers a lot of the toxicology that we don't. So many of our students in the ENGC program have kind of broadened their horizons in toxicology by taking classes there. This is just a list of sample electives, but again, I mentioned before, you can certainly venture beyond this initial list. We have many educational partners who help us constantly improve and advance our curriculum. We work with Sustainable GW. Here at GW, we work with a great NGO out of Boston called Beyond Benign that's trying to bridge toxicology and chemistry in higher ed. We also are part of these research, safer chemical research networks or research consortia, such as the Modern network out of Yale, and we are registered with Sustainable Scientists, or the NACI organization. You will probably, if you enroll in the ENGC Masters, at some point take on an internship. Typically, that's something that we help with and would start in the summer between the first and second year, and can lead to internships through the second year of part-time employment that you kind of take on while finishing up your class, is something that can greatly help offset some of the tuition costs. Some students in the past have done research, although I would say research is not the primary focus of the ENGC program. It's mostly oriented to give you a robust skill set to then apply it in the context of policy or advocacy. But there are faculty, of course, associated with this program, the core faculty teaching the classes at GW that I mentioned. So you could work in Houston Miller's group, laser analytics. You could work in my group if you're interested in computational modeling at the intersect of green chemistry, toxicology. You could work in Lauren's group. She's on a call, so you can talk to her afterwards about it. She studies uses synchrotron spectroscopy to look at interfaces in the environment and how molecules behave at those. I hope I didn't butcher it, Lauren. And finally, financial aid. So this is something that I think can be addressed after this presentation in more detail, probably by someone other than me. But there are fellowships that are available through the Columbian College of Arts and Sciences. some are for international students or targeting international students specifically. You can also apply to be a teaching assistant in the department. There are, of course, campus jobs. And as I mentioned, most of our students take on paid internships as during the summer between the first and the second year. And many of them go on to take part-time jobs in their second year to help with the costs. Yes, here's the website and the contact for the graduate student assistantships and fellowships. And as far as where our graduate students go, so a lot of our past graduates have gone to the US EPA. Some have gone to work for the trade group for the chemical industry, which is the American Chemistry Council. Some have gone to work for Syracuse Research Corporation, which is a big contractor to the government across many different segments of sciences. Variety of consulting groups like Climco and Joe Group and Battelle. So it really spans a wide set of organizations and different expertise that you can leverage with this degree. We have had some graduates also to go to law school and pursue environmental law. If you're interested in knowing more beyond just this call, this session today, you can join our LinkedIn group. The link is up here. We also have a broader group of GW alumni. If you ping us, our department, we can and are interested in knowing about specific careers, we can certainly connect you with some of our ENGC alumni that have taken on those particular jobs and gone on those careers. So you can learn from them to know more. Right? That's all from me. Thank you.